Hello guys, and welcome to my presentation about slide bearings and lubrication. Let's start off with a question here. What is a slide bearing and why do we need lubrication? Well, glad you asked. Slide bearings are basically bearings which take loads in certain directions, and we use bearings to basically reduce costs and make serviceability easier. And lubrication will basically just extend the lives of the bearings by reducing the coefficient of friction, and thus you get more use out of your product. So there are two main types of lubricants. We have solid and liquid lubricants. Each have their perks and benefits. We won't go into them though. For solid, we have graphite and gas. So as we could see from the pictures at the bottom, graphite lubricant is a solid lubricant from the powder observed there, and it's useful for many applications. One of which is a stuck door lock. It can be very useful for that. And on the right hand side, we have a little uh, mechanism to actually use a gas lubricant, as you gotta capture it somehow. You can't just use the gas from the atmosphere. It has to be contained somewhere to use it as a lubricant. And next up, we have the liquid lubricant. And liquid lubricant is classified based on its viscosities and properties. On the very left hand side, we have something called superlube, and superlube would be a grease. It's considered a liquid lubricant, but it's just a very viscous lubricant, if you want to put it that way. In the middle, we have dot 5.1 brake fluid, and on the very right hand side, we have 10W30 motor oil. And yeah, that's basically it for both these types of lubricants here. Now, we're going to go a little bit more in depth of lubricants. So, like I mentioned before in the previous slide, there were two main types of lubricants. That we had oils and greases. So, oils, there are a couple major classifications for oils and properties. So, one of which is pour point depressants, and this causes the oil to flow at lower temperatures. Next up, we have viscosity index improvers, which have less variation of viscosity with temperature. Then we have defoamants, which resist foaming when agitated in high-speed machinery. So this is especially necessary in, let's say, your car, where the oil is moving at insane pressures, like 60 psi, and without those defoaming agents, it's not going to end well, I'll tell you that. After that, we have oxidation inhibitors. So oxidation inhibitors resist oxidation at high temperatures. Oxidation can be terrible for your engine because it can create a mixed film boundary, which we'll get into later, and that's not too good for your engine, if I do say so myself. It's not bad per se, but it's not good, you know. Next up, we have corrosion inhibitors. So this prevents corrosion of metal surfaces. We have detergents and dispersants, and this minimizes the formation of engine deposits. So it serves as a nice cleaning, little soap and water for your engine. Not really, but you get the gist of it. Then we have anti-wear additives. So this reduces the friction and wear. Again, this is what leads to that lower coefficient of friction from using a lubricant and compared to just dry on dry action. Next up, we have greases. So greases are thickened oils, like I mentioned before. They have a really high viscosity. They're designed to stay in place. They're very cost effective. So in a area where, I don't know, like putting the liquid oil would be too expensive, or it's just wouldn't work. We have grease, and grease is not bad. It's just not as good as liquid oil, but it's not bad by any means. And it does have some benefits, like it prevents contaminants from affecting the bearings, so this results in a long-lasting operation, and it also serves a cooling and cleaning function. So we're going to go into sliding bearings. So this is the type of bearings we're going to be looking at today. So sliding bearings take direct sliding force from the load-carrying members, and we have two main types of sliding bearings. We have journal bearings, which support a radial load. We have thrust bearings, which support a load in the direction of the shaft axis. And these bearings are made from materials such as bronze and babbitt. And they're designed to be easily replaced, so they have the serviceability in mind. and it can be utilized as a whole ring or halves. So we have an example of a half ring right here. It's all the way to the right hand corner, and this is a journal bearing, which is used for the crank, not the crank arms, the rods of your engine. And as you can see, it's split in half, and it's one of the orientations that we could use these bearings. And on the left hand side, we have a thrust bearing, and this thrust bearing belongs to a 13B rotary engine, and it's used to actually space out the uh, pulley, the crank pulley, and the actual shaft, the input shaft, on the front input shaft, my fault. And finally, we have lubrication and sliding bearings, and we're going to see how these two amazing elements intertwine with each other. So lubrication is classified based on the degree it separates the bearings and the opposing surface. First up, we have hydrodynamic lubrication, which occurs when the two surfaces are completely separated by the lubricant. At its thinnest point, its thickness is 0.008 to 0.02 millimeters, which is amazing. And this results in absolutely minimal wear. And coefficients of friction are usually just there due to the actual oil, and it's insanely low at 0.02 to 0.01, which is practically nothing, and that's why we see so much life out of engines these days. Next up, we have mixed film lubrications, which result in some dry collision between the two surfaces, yet not as detrimental as boundary lubrication, which we'll get into in just a bit. And its friction ranges from 0.04 to 0.1. And next up, worst but not bad based on your application, I guess, boundary lubrication, which results in constant contact between two surfaces. However, we got to factor in lubrication here, and lubrication is Jesus. And this will minimize the wear, and friction will range from 0.05 to 0.2. God bless lubrication. Anyways, we have three main types of lubrication, and its properties and how it reacts with sliding bearings. And up there on the right, we have the different types of lubrication in the sense of tires. So this is hydroplaning, or the concept of getting to hydroplaning, I guess. But when you see it as normal, the very first kind of image there, that would be boundary lubrication. So that's the tire directly contacting the road. Next up, we have the transition, which can be looked at as mixed film lubrication, and that's when some contact is made with the road and some contact is made with the water. And then we have a full hydroplane, which can represent our hydrodynamic lubrication, which is a full separation between the two surfaces through the film. The end. If you have any questions, please let me know, and it was a pleasure presenting this. My name is Kuru, and I'm gonna head out.